In this example, we would like to find dy dx if x cubed plus y cubed is equal to 6xy. The graph of this equation looks something like this. It's got this little loop in it there. It's called the folium, from the word foliage, like a leaf. The folium of Descartes, René Descartes. Okay, so we would like to find the slope of this folium of Descartes using implicit differentiation. Implicit differentiation. So the key there is to take the derivative with respect to x of both sides of the equation. The derivative of x cubed plus y cubed equals the derivative of 6xy. Now the derivative of x cubed plus y cubed, let's see, the derivative of x cubed is 3x squared. And the derivative of y cubed is a little bit more subtle because these letters don't match. So we have to remember that when we're doing implicit differentiation, we are assuming that y is a function of x for the purpose of the calculation. Even though in the picture, clearly y is not a function of x, it doesn't pass the vertical line test. But that's okay for the calculation to assume y is a function of x. So here y cubed is a composition. Y is the inside and the cube is the outside. So when we want the derivative of a composition, we use the chain rule, and that says take the derivative of the outside and multiply by the derivative of the inside. So the derivative of the outside is 3y squared, and then times the derivative of the inside. The inside function is y, and its derivative is y prime, or I'm going to use the notation here, dy dx for the derivative. Okay, so now equals, continuing on to the right side, we want the derivative of 6xy. To find the derivative of 6xy, we have to use the product rule. We have a product of two functions here, 6x, which is the first function, and y, which is the second function. So according to the product rule, the derivative is the first, 6x, times the derivative of the second, dy over dx, or y prime, plus the second, which is y, times the derivative of the first, which is 6. So y times 6, or 6y. Okay, so now we have to solve for the symbol dy dx. So we're done with the derivatives. Now we just solve this equation for the symbol dy dx. We put the dy dx's on one side and the non-dy dx terms to the other side. So I'll put the dy dx on the left. 3y squared times dy dx minus 6x times dy dx is equal to the right side, which is 6y is already on the right, minus 3y squared gets moved over. 3x squared. 3x squared. Now the reason for that last move is that dy dx can be factored from the left side. The left side is dy dx times 3y squared minus 6x. And then copy the right side, 6y minus 3x squared. And finally, we can divide to find dy dx. Dy dx is equal to the right side, 6y minus 3x squared, divided by 3y squared minus 6x. And we could simplify this a little bit. We could factor out a 3 on the top and the bottom and cancel it. So if we factor out a 3 and cancel it, we're left with 2y minus x squared over y squared minus 2x. So this formula will tell us the slope of the tangent line to the folium of Descartes at any point xy.